Okay, now let us first discuss about the Docker, and then we will discuss about how to install the Docker on a Ubuntu machine, okay, on a Linux machine. So now, when we are discussing about Docker, Docker is a containerization platform. Docker is a containerized uh, containerization platform. Okay, or else I can call it as an engine. Okay, what is the main functionality of the Docker? The main functionality of the Docker is to hold the containers. Hold the containers. What will be there inside the containers? Inside the containers will have applications. Okay, so what are the applications that we want to execute? All the application will be there inside the container. Now, what is the major difference between the uh, what I can say conventional typical method or conventional method, old method which we are following, as the difference between the containers, typical servers and the containers. So now when we go back some 10-15 years back, we used to have the servers. Okay, we are having some servers. So those are the physical servers which are having huge amount of resources like CPU, RAM and storage. RAM and storage. Now, what we have to do for this physical server, we need to install an operating system. So which type of operating system? It might be a Linux operating system or a Unix operating system or Windows operating system. So these are the operating systems which we are installing on the servers. So Linux means your Red Hat Linux, Debian, like Ubuntu, okay, CentOS, SUSE, Parrot, these are all comes under the Linux. When you come to the Unix, Sun Solaris, this will comes under the IBM Unix. These are all comes under the Unix. When you come to the Windows, you know about that. Windows Server 2000, 2008, 8 R2, 2012, 12 R2, 2016, 2019, 2022, latest 2025 is also about to come. So these are all the server operating system. We have to install that on the servers. And after installing OS, we need to, when we are installing the operating system, kernel is also installed. What is this kernel? Kernel is a management component. Management component of OS. So simply, if I have to tell you in your development, it's like a compiler. Okay, kernel is a compiler which will compile the user request and forward it to the hardware. Okay, so that is called as a kernel. Now the next one is, now this is about your servers. Now after installing operating system, now we are installing the applications. We have to install the applications. Okay, which type of applications? They might be Java application, Python application, or else Ruby applications, any applications. For that, we have to install the dependencies. For installing those applications or else to create those applications, we are having the dependencies like Java dependency. In Java, there will be several versions. For example, Java 11. These are the versions, Java 17, Java 18, like that. You have to install the dependencies depending upon your application requirement. Now, when we are running these servers, we have to install all the operating system, and then we have to install the dependencies, and then we have to run the application. Now, for example, the servers are having the huge amount of resources. Servers won't have like our normal laptops. Servers are not like our normal laptops. These are called as client missions. Okay, the normal laptops which you are using are the client missions, or else desktops which you are using are the client missions. So you will have single CPU, one CPU, where you will have octa-core processor, or else quad-core processor, or else hexa-core processor, like that. And you will have 16 GB to 16 GB of RAM, 8 GB of RAM, like that. So the processor which you are using on your laptops are completely different from the processor that you are using on the servers. So the server processors are high-end processors. They will process huge amount of data at a single time. Okay, so when you come to the RAM also, the RAM is also very, very high, like 64 GB, 128 GB, 256 GB, like that. So when you compare the physical servers are having huge amount of resources. So you can install multiple applications. But the point what you need to understand here is, so the application which I was installed firstly, whenever I have configured my server, physical server, whenever I configured my physical server or else install the operating system on the server, I installed Java 11. I installed Java 11. On the top of Java 11, I created my application. Now, there is an new application which should be on the which should be created on the Java 17. Okay, so there is application 2 which should be created on Java 17 system. On the operating system, Java 11 is there. But am I able to run the Java 17 application? It is not possible. Why? Because there is a dependency mismatch. So definitely I need to my Java 11 to Java 17. But if I upgrade application, it will not work. So okay. So now what I have to do? So to overcome this problem in the good old times,
No, Chaitanya, your voice is
IT
breaking.
Hello,
was
yeah.
virtual.
Hello, Chaitanya. Yes. Hello.
From when it is breaking.
No, Chaitanya, hello.
Hello, yeah. Your
Hello.
voice is breaking from past 2-3 minutes.
Then you have to intimate at that time, right?
Oh, I
Am I
thought it
audible
was
now?
only for me. Yeah, now you're audible. Intermittently, it is being intermittently it is occurring. Hello. Yeah, now you're clear.
Yeah. Thank you. Now, if you can see here, this is my Windows 11 laptop or Windows 11 operating system laptop. On this Windows 11 operating system laptop, what I'm doing, so it is having I am having the resources like I processor with 32 GB of RAM and somewhere it's an i5
No,
processor which I am using
still
right now,
your voice is
and it's a
breaking.
32 GB.
Hello, yeah. Your voice is breaking in between. Sometimes it is clear, but in between it is breaking. I think there is some problem with your machine or mic.
Okay.
Hmm?
Am I audible now?
Yeah,
Yes.
it is good now.
Thank you. So this is my Windows operating system where I am having. I can see if I am having only single operating system, I can run a single application. But now what has happened? The IT developers has developed a new technology called as virtualization, where I can create multiple virtual machines depending on the physical resources. Right now, what are the physical resources that I am having? I have a CPU, which is of 3 gigahertz, and I am having a RAM, which is of 32 GB. Now, what I will do here is, I will try to start an virtual machine. I will just try to start a virtual machine. See here. So hold on. I'll try to start a virtual machine over here. Look at that. It's a Ubuntu machine. So what I am having an operating system called as Windows. On the top of the Windows, I am able to run the virtual machine called as Ubuntu. Okay, and I can perform all the operations, whatever I am doing in my original operating system. The same way I can do it in the virtual machine also. Now, if you can see here, previously it is 10 GB of memory. Slowly the memory is increasing. So how much it is increased? It is increased to 11 GB. So which means that the resources are consuming. Okay, the virtual machine is consuming my physical resources and it is working. Okay, if you see here, there is a one more virtual machine, that is node 1. This is also a Ubuntu machine. So if you can see here, there are two machines which are running, and these two machines are consuming my original physical resources, and they are running their own operating system. You can see here, this is the operating system, Ubuntu operating system. And here also we are having one more operating system, that is the Ubuntu operating system. So I can install Java 11 on this particular operating system, and as well as I can install Java 17 on this operating system. So now what is happening within a single physical machine, I can run the multiple applications. I'm able to run the multiple applications. Okay. So now how we are able to run the multiple applications, because we have created two different servers or else two different operating systems, two different machines. And in those different machines, I have installed the operating system. Try to understand, I just installed the operating system. As I install the operating system, installing in the sense, so how it will be looking like here is, try to understand, I am having the physical hardware. On the top of physical hardware, I have installed my operating system. On the top of that, I created a virtual machine. So in the virtual machine, I have installed an operating system. On the top of operating system, I am installing the, on the top of operating system, what I am doing, I am installing the application. So this is how the work happens. So which means, so this virtual machine has nothing to do with the host operating system. So now if I have to explain you, this is the hardware. This is the hardware like CPU and RAM. And this is my OS, okay, which is Windows. And this is my virtualization platform. This is my virtualization platform called as VMware. And on the top of that, this is the virtual machine. And this is the Linux operating system. And this is the application. Okay. So now if you see here, the virtual machine or else the application has nothing to do with the host operating system. So the Windows operating system is the host operating system. It doesn't have anything to do with the host operating system. Why? Because this application is installed on a virtual machine in which we have installed the operating system. When we install the operating system, the kernel will be there and that kernel will work along with the applications. So we don't need to worry about that. So when we get back to this, if you understand, so what is the main drawback of this virtualization means, if you want to move this entire machine, if this master machine has to be moved from one location to the another location, now I have created on my laptop, on my client machine. Now I want to move this virtual machine from here to my server. That is going to take a lot of space. Why? Because it has to totally convert the images. It has to be totally converted into the image. What it has to convert? It has to convert the operating system, application, and everything. So in operating system, you will have the binaries, libraries, whatnot, source code. So there will be so many things will be there inside the operating system, which it should be packed with the application, and that should be moved from one location to the another location, which is a heavy weighted one. Okay, so this is the drawback. But what is the advantage with the virtual machines? When we are creating the virtual machines are helpful for us to optimizely or else to maximum use our physical resources, physical server resources. Whatever the physical server resources are there, they can be utilized maximum. So that is the main functionality of your main advantage of your virtual machines. So like that, you can create multiple virtual machines here. Okay, up to the physical resources, up to how much physical resources will accept, those many number of virtual machines you can create. On the top of that, you can create multiple applications. Okay, one application will accept .NET. Then you can install a Windows. One application will work with the Python. Then again, you can install an Ubuntu or Red Hat Linux. So now what is happening? We are creating multiple virtual machines, multiple servers on a single hardware. We don't require multiple servers. Okay, we don't require multiple hardwares for this. If we are having a single hardware, then we can divide that into the multiple virtual machines and we can run the multiple operating system and as well as we can run the multiple applications. So that is the main benefit with the virtualization. But what is the drawback? The drawback is to what I can say, mobility. If I want to move this virtual machine from one end to the another end, it is very difficult for me. So to overcome this problem, what I am trying to do here is I am implementing the containers. I'm implementing the containers. So now what happens with the containers? So in the containers, you will have the hardware. On the top of that, you will have the what I can say, operating system, but you don't have this virtualization. Okay, or else, but you don't have this virtual machine. You don't have the operating system. Okay, so now what happens in the container? On the top of the Windows operating system or else any operating system, we are going to install the Docker engine, Docker containerd, any type of containerization platform we are going to install. On the top of that, directly we are going to install the containers. So inside this containers, we will have the binaries and libraries that are helpful for running the application. Okay, so here we don't require the virtual machine or kernel. So simply we can create a container. So now how this container will be managed? So the containers will communicate with the host operating system, and host operating system will the host operating system kernel will manage the entire requirements of your container application. Whatever the application that is required, the application requires some 4 GB of RAM, high processing or else anything. So process management, memory management, network management, everything will be done by the host operating system kernel. Even though you are having the Ubuntu container and your host operating system is Windows, but still this Ubuntu container will be able to communicate with the kernel of Windows operating system. How? Linux is a different environment and Windows is a different environment. How Linux applications will communicate with the Windows kernel? For that, what we are going to do here is we are going to install a concept called as, or else we are going to run WSL, Windows Subsystem for Linux. Okay, if you are having the WSL, then what you can do, the Docker will be installed on Windows operating system with the help of WSL, so that whatever the containers that you are creating on the Docker, Ubuntu containers, Red Hat containers, any Linux containers, they will communicate with the host operating system with the help of WSL and get the resources from the hardware. Okay. So now when we are running this containers, what is happening here? We don't require the virtualization. VMware is not required. Operating system we are not installing. We are eliminating these weighted resources. We are not installing the virtual machine. We are not installing the operating system. We don't have the kernel. So everything will become compact now. So we only have the binaries and libraries of the Linux operating system, and we will run the application inside the container. That's it. So the containers are very lightweighted. So they will be around some 1 GB. So somewhere around 70 MB to 1 GB. In between that only you will have your containers, 70 MB. Okay, inside the 70 MB, you will have the Ubuntu machine, Ubuntu environment where you can create your applications. Now, the point is, it is very easy for us to transfer the containers from one environment to the another environment. I have created this container in the development environment. Now I want to move it into the production environment. I can move it. Why? Because it is lightweighted. I don't have the kernel. I don't have the operating system installed inside the container. I am only having the environment inside the container. I can simply pack the container. So now what I am trying to do, I am converting the container into a image format. So those are called as Docker images. Okay, a container will be converted, or else what is a container? A container is a writable format of an image. Okay, what is an image? So whatever the applications that are there inside your container, those will be inside the image. Okay, if at all, if your container has to have some Ubuntu environment, which should have the Nginx installed inside that. So now how you will create that image, or else how you will create that container with the help of an image. So images are the readable format, read-only format of your containers. Images are the read-only format of your containers. And with the help of images, what you can do, you can create the containers. And these images can be easily migrated from one location to the another location. So the most important point what you have to understand here is a containers are created with the help of images only. Okay, understood about this content? Any questions here? So do you understand what is the main difference between virtualization and containerization?
Yes.
I'm asking everyone. What did you understand from the containerization and virtualization? Everyone.
Yes.
Yes, you understand. Now tell me what did you understand?
So virtualization is like creating a complete system with operating system, whereas containerization is a smaller image where we will have required libraries to have the application running, and containers get hosted on containerization engine, whereas virtualization happens on a proper operating system on a physical machine.
Exactly. So that's about your the difference between containers and virtual machines. Now, first what we have to do, we need to install an Docker. We need to install the Docker on our Ubuntu machine. Okay, so either I can install on this Ubuntu machine, or else you can install on the Linux. If you are having the what I can say. Um, yeah. So hold on. Good. So already I have the Docker install on this. Okay. Okay, good. So now what I will do here is I will create another Ubuntu machine in my what I can say in the EC2 instance, like in my AWS account. An instance I will create. So yeah. So I will take this IAM, any Ubuntu operating system. It is also a Ubuntu operating system. If you see here, the platform is the Ubuntu platform. You can create in the Red Hat also. Don't ask me that, sir, can't we create in the Red Hat? You can create in any Linux environment, in any Windows environment. You can create the Docker. You can install the Docker. It is not like that. Okay. So in my AWS account, I have created an EC2 instance, and now I am trying to access that EC2 instance, and I will install the Docker on that EC2 instance. Look at here. Sir, those who doesn't know about AWS, then what we have to do. So that I will tell you in the next session, but concentrate on this. Get there. So right now Docker is not installed on this machine. Okay. So now what I will do here is apt update -y and apt install -y net-tools. What is this net tools? These net tools are used to know how many adapters are there, how many network adapters are there. So network adapters are nothing but the Ethernet ports. So simply if I have to tell you in a non-technical language, those are nothing but the Ethernet ports, which will allow the internet to come for a mission. Okay, simply. So see here. On okay, if config. So now if you see only 2 Ethernet ports are there. Now what we have done here, we just created a server. There is a server. Okay. So if I want to access the internet, if this server has to access the internet, so there should be an Ethernet port. For this server, there should be an Ethernet port, and this from this port we can access the internet. Okay, so that Ethernet port is ETH0. You can see on the server there is a ETH0 is there. So this is the Ethernet port for the server. Okay, good. So what is the loopback address? Loopback address is given for the testing purpose. So only two Ethernet ports are there, and among those, this one is the imaginary port. This is the actual port that we are having, and this is the IP address of the server. 172.16.100.22 is the IP address of the server. Now, when we install the Docker, how we are going to install the Docker? So there are two methods to install the Docker. So it's your wish. Either you can go in any one of the method. Either you can go with the normal installation process from Google. You can check out this. Install Docker on Ubuntu. So these are the steps you have to follow. Or else what you can do. So all these steps you have to follow, or else. So get.docker.com. If you go to this website, you will have all the commands in a shell script mode. Simply, you have to run that shell script in your in your machine, in your Ubuntu machine. See here, curl-sl https://get.docker.com. If you give it, it is going to show you the entire shell script. This shell script has to be executed. Now, how I will do? Simply give bash. Okay, when you give bash over here, pipe, this is called as a pipe symbol, and then bash. Now, what is going to happen? It is going to install the Docker on my Windows machine. Sorry, on my Ubuntu machine. No, sir, I want to go with the conventional method. Simply, you can go with this process. The same will be there. Okay, so you can go with this process, apt update and apt install the Docker. This is the latest, and if you want any specific version, you can go with the specific version, and then you can execute the commands. So every command is all the commands are similar. Whatever the commands that are executed over here, the same commands are available in this configuration also. Both are the same. Okay, so now if you can see, we are able to install the Docker. So hold on. On. It has to install the Docker. Hold on. It is not installing. Come on. Okay. Once after the Docker is installed, then if you check out the Ethernet adapter. So now what happened in this server, we have installed the Docker application, Docker engine. Okay, once the Docker engine is installed, then what is going to happen? So taking too much of time. It is going to create a new network adapter. Right now we are having two network adapters only inside the server. But once the Docker is installed, it is going to create a new network adapter. This network adapter will be in contact with your bridge network. So now if you create any container in the Docker, if this container has to communicate with the internet, so by defaultly, it will be connected to your default network adapter that is created with the Docker. So whatever the network adapter that is created with the Docker, so the container will be defaultly connected to that network adapter. And this network adapter is called as a bridge adapter. So now the container will communicate with the bridge adapter, and from the bridge adapter, the data will be forwarded to your Ethernet port. And from the Ethernet port, it will be reaching to the internet and gets the data, whatever the container is requesting for. So now if you see here, look at that, Docker is installed, Docker info. You give this, it is going to give you the Docker info. Okay. So now if config, so see here, previously we are having these two adapters. Now when we install the Docker, automatically a new adapter called as Docker 0 has been created. And this Docker 0 is the bridge network adapter. Docker 0 is the bridge network adapter. So when you create a container, this container will communicate with that bridge network adapter and goes to the internet. The request will be going to the internet. So now let me create a container. Docker run -itd -name test container or test1 and Ubuntu. Simply I will give like Ubuntu. So what is the meaning of this entire command? Docker run. So you want to create a container and the container should start. Run in the sense the container should be created and it should be started. Okay, Docker run -itd. -itd in the sense I means interactive. So the user has to interact with the container. T means a terminal should be created, interactive terminal. IT means interactive terminal. And D means whenever we create a container, that automatically the user should not be logged into the container. Okay, it should be in the detached mode. If I don't give D, what is going to happen here? I am not going to provide D. Okay, and the container name is test1 and the with the image Ubuntu. I said, if you want to create any container, definitely you have to provide the image name. Okay, so I am not giving D. Try to look at this. So right now we are on the server. How you can say we are on the server? So root user is logged onto the server, which is having the host name as 172.16.122. Okay, this is the server host name. Try to understand 172.16.122 is the server host name. Now, when I try to create the container, look at that. If I don't give D, now where or else where the current user is located, look at this. So here you are having a different name of the server. Here you are having a different name of the server. What did you understand from this? Aren't we logged into the container or not? Are you able to understand? Are you able to find out the difference over here?
I think we logged into the container, right?
Yes, exactly. So we have logged into the directly into the container. Why? Because here we did not give D. D means detached. So now ls-la. So the same. So this is the Ubuntu environment. If you want to check out cat/etc os-release. If you see here, what is the environment? It's an Ubuntu 24.04 environment. Okay. So with the help of this Ubuntu image only, we have created the container. Now to come out of the container, Control PQ. Press Control PQ button, you will be out of the container. Now if you see the difference over here, here it is 2C9A, here it is IP 172.16, which means that we came back to the server. Okay, so now if you can see Docker PS, look at that. Docker PS, if I give this command, a container with the name test1 is running and the container ID is this. So previously we are inside the container only. So if you can see here, previously we are inside the container only. Okay. So now if I give like this, docker run -itd -name test2 Ubuntu. Okay, so I want to run a container. This time I have given the D. D means detached, which means that the user will not directly logged into the container. Okay, so now if you can see Docker PS, two containers are running. Test2 is also running, but the user is not directly logged into the container. Why? Previously, why the user is directly logged into the container? Now, why user is not able to log into the container? Why he did not log into the container? Why the user is directly not going into the container? Previously, why he has gone into the container?
Now we have given the detached mode. So
Yes, now we have, as we have given the detached mode, the user is not inside the container. So that is the main difference. What is the meaning of ITD? I means interactive terminal, D means detached. Okay, so we have created two containers, and these two containers will be able to communicate with the internet. So why? Because the containers are connected to the bridge network adapter. How you can say that they are connected to the bridge network adapter? So to check what are the network adapters that are in the Docker network ls. If you give this command, so if you can see, this is the bridge driver. Bridge driver in the sense, this adapter. Bridge driver means this adapter. Okay. And host driver, here you can see host. What is host? Host means this adapter. This is the host one. Okay. So, and the next one is loopback adapter. None means loopback adapter. So now this is the bridge adapter. So now if you inspect the bridge adapter, Docker inspect network, Docker network inspect bridge. So see here, there are two containers that are created in that bridge adapter. So the first container is having the IP address 172.17.0.2, and the second container is having the IP address 172.17.0.3, which means that the two containers are created under the bridge network. Under this network, we have two containers running. And if we log in into these two containers, so I am going to log in into these two containers. How I can log in? So to log in into the container, docker execute -it, container name is test1 and bash. When you give this command, so now you will be inside the container. So ping will not be there. Okay, if config will not be there. Any minor utility is also not going to be there in your container. Why? Because if you see the image size, okay, if you see the image size, Docker images, so these two containers are created from the Ubuntu image, which is having the size of 78 MB only. So that is the reason it doesn't have any minimal utilities also. Don't go for the applications like what I can say, internal applications of the Linux, like what will be there, Firefox and all the things will not be there. The basic utilities are also not going to be there inside your container. You have to install it. So if I want to install that, so let me log on to the container again. Okay. Now what I will do, apt update -y and apt install -y net-tools IP utils -ping. Okay, these are all I am going to install on my container. Okay, good. So after installing that, if I go for ping google.com, previously ping is not there, but now we have installed the ping. How we have installed IP utils -ping? It is the utility for installing ping. And now I want to install any another applications. Okay, apt install -y unzip. I will install unzip also. Okay, so like that you can install everything. So now there is a container which is having the utilities of sorry. there is a container which is having an utilities of ping, if config, or else unzip. These are all available inside the container. So now if you can see Docker PS, there are two containers. In test one, I have installed all the related applications. Now I can convert that container into an image. So how I can convert that container into an image? Docker commit test one to Ubuntu latest, or else Ubuntu version 1. Okay. So now an image is created, Docker images. So see here, Ubuntu latest is having 78 MB and Ubuntu version 1, which is created from this container test 1. So it is an image which is created from the container called as test 1. It is having a size of 128 MB. Now, what is the main difference between these two images? What is the main difference? Why it is having 78 MB? Why the latest one is having 121 MB?
We installed some additional softwares, right?
Yes, we have installed. So with this explanation, or else with this practical, what did you understand? What is an image? Image is a read-only format of the container. Will you accept it or not?
Yes.
If I create another container with the help of this image, so see here, docker run -itd -name test3 Ubuntu version 1. So Docker PS. So look at that, test3 is created, a container with the name test3 is created. Now if I log in into that container, docker execute -it test3 bash. Now I will have all the utilities. If config, it is there. Ping google.com. Previously it is not there. Now it is having the ping utilities also there. So how I am able to get all these utilities? Because in the image of this Ubuntu latest, I don't have any sort of images or also any sort of utilities. But when you come to the Ubuntu version 1, I am having all the utilities. How I am getting that? Because inside the container, I have installed that and converted that container into an image. And with the help of that image, I have created another container. So whatever the applications that are there inside that image will be there inside the container. Okay, so what I can say, containers and images both are the same. Containers are the writable format of the images and images are the readable format of the containers. Understood? Am I clear with this?
Yes.
Everyone? Any questions? Any questions?
I think we are good.
Okay. Fine. So that's about the concept of your containerization. That's about your Docker, how practical implementation. In the next session, we will go in deep into the networking concept, and then we will go back into the Docker images. So by the end of this week, or else, so today or tomorrow will be the last demo for you. And from Friday onwards, you will have the paid sessions. Okay, by the end of this particular week, we have to complete the Docker. Let us see whether we can complete it or not. So that's it from my end. We will meet in the next session and discuss more and more topics.
Chaitanya,
Yep.
so do you have any kind of document with, if I wanted to practice, right? With all these comments and all.
You will get the document. Not right now, but yes.
Okay. Okay.
Any further questions?
Nothing so far.
Yep.
So we'll get this recorded video from Friday?
Yeah. From Friday, you will get all the videos.
Okay. Done.
I did not went on for after demo. I did not went on for the session. Okay, don't worry, Anil. Okay then.
Thanks for.
Thank you.
Yeah.
Yeah.